Howdy, students. When you use a thermometer to measure temperature, it tells you what the temperature is now. There's no way to use a thermometer to figure out what the temperature was 1,000 years ago. All the measurements we talked about in the previous videos are like this. They are direct measurements that only tell you what the temperature is at the moment the measurement was made. Such direct measurements cover the time period that people have been systematically recording the world around us with sufficient coverage to get a picture of the global climate. This gives us a good picture of the temperature for the last century or so. But we like to know how temperatures varied even further back, even before humans were around. This will tell us if the warming we see in the modern record is unusual or not. For this, we need something we can measure today that tells us what the climate was at some point in the past. We call these climate proxies or paleoproxies. An ice core is a good example. Ice cores are obtained by drilling down into a glacier or ice sheet with a hollow drill bit and extracting a cylinder of ice a few inches in diameter. We know that the deeper into the glacier you go, the older the ice is. Scientists can use estimates of how fast ice is accumulated on a glacier to figure out the age of ice at any depth within the glacier. Then they can analyze the chemical composition of the ice to determine what the climate was like when the ice was formed. Using this technique, we can extract a climate record going back about 1 million years. Make sure you read the book because this is described in more detail there. But the key thing here is that these climate proxies allow us to see a detailed picture of the climate from long before humans were recording any data. Various proxies give us different windows into the climate. Measurements of tree rings give us climate information going back about 1,000 years, and it covers regions where trees grow, mainly over land in the mid-latitudes. Ice cores give us information about the climate back about 1 million years, but mainly in colder regions where permanent ice exists. Ocean sediments, which slowly accumulate at the bottom of the ocean, contain a lot of useful climate information. Sediments are attained by special scientific drill ships, and these can reveal the details of the climate back nearly 100 million years. Combining all proxies together gives us a reasonably complete view of the climate of the Earth going back to the time of the dinosaurs, with some indicators of climate going back much further. So what do these data tell us? Again, read the book. There are a lot of details in there that I expect you to know, but here are a few highlights. First, there's geologic evidence that liquid water has existed on the planet for most of the Earth's 4.9 billion year history. This tells us that the temperature of the planet has remained in a range consistent with liquid water. This plot shows the lowest latitude that ice reached over time. We see that there were periods when the Earth was mostly ice-free. As the plot on the right shows, there's no ice anywhere on the planet. There were also periods when the ice was mainly ice-covered. For example, 300 million years ago, ice extended from the pole to about 25 degrees latitude in the tropics. The right-hand panel shows approximately what the ice coverage would look like. Periods with significant ice coverage are known as icehouse worlds, while periods without much permanent ice on the Earth were known as greenhouse worlds. Do not confuse these icehouse, greenhouse worlds with ice ages and interglacials, which we'll discuss in a minute. Now let's look at the last 70 million years. This plot starts 67 million years ago, right about the time the dinosaurs were killed by an asteroid. This was the Eocene, a greenhouse world that was so warm there was basically no permanent ice on the planet. If you were beamed back in time to the Eocene, you'd barely recognize the world. There were crocodiles and other frost-intolerant plants and animals in the Arctic, palm trees in Wyoming. It looked like a different planet. Since the Eocene, temperatures have been declining. We'll talk about that more in Chapter 7. So if I ask you on the exam how the Earth's temperature has been changing over the last 67 million years, the answer is that temperatures have generally been declining. But for now, Let's zoom in on the last 5 million years. This plot shows the decline in temperatures in more detail. You'll notice that about 3 million years ago, we start seeing oscillations between warm and cold periods. The cold periods are known as ice ages, and the warm periods are known as interglacials. Let me reiterate that these ice age interglacial cycles are different from the ice house greenhouse cycles we talked about a few minutes ago. Zooming in on the last 400,000 years shows ice age interglacial cycles occurring over this period about every 100,000 years. Most of this time is spent in the cold phase, the ice ages, while the warm interglacials only last 10,000 years or so. We reached the depths of the last glacial maximum about 20,000 years ago, and over the next 10,000 years, the planet warmed up to the interglacial that we are now living in. It is important for the exam to remember that the Earth was about 6 degrees Celsius colder during the last glacial maximum 20,000 years ago. This warming since that time looks rapid on this plot. 6 degrees in 10,000 years, about 1 degree per 1,600 years. However, that is slow compared to the present rate of warming. We've warmed about 1 degree in 100 years, a rate 16 times faster. Keep that in mind throughout this class. As far as climate change goes, we have the pedal to the metal. If we look at the last 11,000 years, we can clearly see the end of the recovery from the last ice age. Temperatures peaked about 7,000 years ago and have declined since then, until very recently, of course. The cooling bottomed out in a period 200 to 300 years ago, a cold period referred to today as the Little Ice Age, during which temperatures were about 1 degree Celsius colder than today's. It is important to know when the Little Ice Age was for the exam, as well as how much colder it was than today. The Little Ice Age ended when we started experiencing the abrupt warming that continues to today. As we'll talk about in Chapter 7, this is due to humans. If not for carbon dioxide emitted from fossil fuel combustion, we'd now be living in a long slide into the next ice age in the next 10,000 years or so. However, due to human activities, all future ice ages have been canceled for the next few 100,000 years at least. To conclude, the paleoclimate record tells us a few important things. First, climate has varied widely over the Earth's history, from a world covered almost entirely by ice to a world with no ice. We also see climate varying before humans were around. Clearly, natural processes can cause large changes in our climate. Thus, when we look at the causes of the recent warming that's occurred over the past century or so, we'll have to explicitly consider whether natural processes could be the cause. And now, your moment of dog.